Today we're talking about solving systems of inequalities. And just like when we were solving systems of linear equations, we have to plot both graphs on the same coordinate plane. So we're going to start with this first inequality here. Y is less than negative 2x plus 3. We're going to go ahead and define the slope. That's always going to be the coefficient of x. So the slope is negative 2 or negative 2 over 1. And the y-intercept is a positive 3. So we're going to start at 3 on the y-axis, and we're going to go down 2 over 1, down 2 over 1. And we're going to go back to the symbol and just double check. Do we need to make it a solid line or a dashed line? Because it's just less than instead of less than or equal to, we need to make this a dashed line. So make sure when you're writing this in your notes, you have a dashed line. Also make sure you're labeling your axes from negative 5 to 5. Just extend this a little bit. And we're going to put arrows on the ends. And now we're going to shade. So remember, when we go to shade, we're going to double check the point, preferably a point that does not fall on this line. So if 0, 0 does not fall on the line, that's usually a pretty good one to pick. So we're going to check 0, 0 to see if that's part of the solution or not. So we're always going to start with the original inequality. So I'm going to check the point 0, 0 in our original inequality. So I'm going to substitute 0 for x and y. So this is negative 2 times 0, which is 0. This says 0 is less than 3. That does check out, which means 0, 0, the origin, is part of this solution. So we're going to shade so that we include that point 0, 0. Okay, now we're going to do the next one, and I'm going to choose a different color for this one. Let's go with blue. So again, we're going to define the slope. The slope is 3 or 3 over 1. Y-intercept is negative 2. Starting at negative 2, we're going to go up 3 and over 1, up 3 over 1, and so on. And we're going to check the symbol again. Again, it does not have a line underneath it, which means I have to make this a dashed line. Okay, we're still going to put arrows on the end. So remember, because I'm making this a dashed line, that implies that none of the ordered pairs that fall on this line is part of the solution of this graph. It's only the ordered pairs in the shaded section of this graph. So now I'm going to check to see if 0, 0 falls in the solution or not. So check 0, 0. Always start with the original inequality. And I'm just going to substitute 0 for x and y, exactly like I just did a little while ago. So I get 0 is greater than negative 2. That is a true statement. That does check out, which means, again, 0, 0 is part of the solution. We're going to go ahead and make sure we shade including 0, 0. If this did not check out, we would shade away from it. So this was the line we just graphed. We're going to go out from that line and shade. So the solution of this system of equations, or of inequalities, is wherever the two shades overlap. So I am actually going to see if I can just highlight that section. So we can see all in here is where the two shades overlap. Okay, so all of this is the solution of this system. And the way we're going to represent that is by writing an S. And I usually circle it. Okay, so that's the solution. So even though we do have a section over here that has some shading in it, we have a section here that has some shading in it, the solution is only where the two shades overlap. And so we're going to go ahead and continue talking about this in class. See you then.